Hello everyone and welcome to the 5.5, 5.6 notes part 2, where we're going to be focusing mainly on proofs, specifically proofs of types of parallelograms, aka parallelograms, rectangles, the rhombus, and squares. So before we get into everything, I want to let you know that there's going to be two types of proofs. There's going to be our normal formal proofs, either by flowchart or by two-column. But in the last slide, we're also going to be talking about coordinate proofs, proving from a coordinate plane, and here we're going to be mainly using this type of proof to prove squares, rectangles, and the rhombus, versus a proof with a two-column. We're going to prove a parallelogram. But before we get into any of that, let's talk about the properties of a parallelogram that we've talked about this week, just to be formalized. If a quadrilateral is a parallelogram, then what is true? Well, by definition of a parallelogram, I know that both pairs of opposite sides must be parallel. So if a quadrilateral is a parallelogram, then both, you must have the word both, pairs of opposite sides are parallel. You also know that both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. You know that both pairs of opposite angles are also congruent. And please just make a note to yourself that you do need this word both, otherwise it's not truly a parallelogram. Both pairs of opposite angles are congruent. And also, we knew stuff about diagonals from the algebra section, that if you have a parallelogram, the diagonals bisect each other, meaning this diagonal chops this one in half, and this diagonal chops this one to be equal to that one. So another reason would be the diagonals bisect each other. Now, we do not know that the diagonals are congruent, and if you look at a parallelogram, it's slanted one way, so this diagonal is definitely larger than this one, so they definitely cannot be congruent. One not as popular reason, but is also something you know from a parallelogram, is if these two pairs of angles are congruent and these two pairs of angles are congruent, these consecutive angles, or same side interior, must be supplementary. So I'm also going to write a note that if you have a parallelogram, you know that same side interior angles are supplementary. And the reason you know that is because if you view these as the two parallel lines and this is your transversal, these must be same side interior. To talk about the converses then, this page we said if we're given a parallelogram, we know these things are true. But what we're going to be using a lot today in this video is the converse. If blank, then you prove a parallelogram. So notice again the theme back here about both pairs of a lot of things. That theme is going to continue here. So let's start with the similar first one. If you have a shape where you can prove that both pairs of opposite sides are parallel, then it must be a parallelogram. So if both pairs of opposite sides are parallel, then it's a parallelogram. In the same way, if you can prove that both pairs of opposite sides are congruent, then you have a parallelogram. Both pairs of opposite sides congruent. Just like earlier, if you could prove that you have two pairs of opposite angles being congruent, then it has to be a parallelogram. Both pairs of opposite angles are congruent. If, like earlier, you could prove that the diagonals bisect each other, then that's another way. If the diagonals bisect each other, then it's a parallelogram. So far, everything is the same as this previous slide. Now, if I go back a minute, you might remember the last reason I said was if I knew it was a parallelogram, I knew these two lines were parallel, so I could say same side interior sup. But if I'm trying to prove a parallelogram and I just have this basic shape, if I pull this away, if I just look at this basic shape, if I don't know if it's a parallelogram, I don't know if I have same side interior because I don't know if these lines are parallel. So that can't be a fifth reason, unfortunately. However, we do have kind of an unusual fifth reason, and I'm going to start because sometimes it comes up on SAT, ACT. Let me show you what it says first, and then I'll prove it. If you happen to have one pair of opposite sides that are both parallel and congruent, then you have a parallelogram. Let me show you why. If you draw a parallelogram down here, this is not the best one ever, but if one pair of opposite sides are parallel and that same pair are also congruent, what we could do to prove this is if I drew a diagonal in, and that diagonal is congruent to itself, if these two lines are parallel, and this is a transversal, this angle and this angle would have to be congruent because of alternate interior. So this triangle has side angle side, and this triangle has side angle side. So because these two triangles are congruent, I could say that because of corresponding parts, this side is equal to this side, so I would have this is definitely a parallelogram because both pairs of opposite sides are congruent. So I could do this proof each time, or I could just say if I happen to have one pair that's both parallel and congruent, this works as a reason to prove a parallelogram. So let's focus first on recognizing when things work and when things don't before we jump into proofs. I have 4 different diagrams for all 4 problems, so it's easier to see. Decide whether you're given enough information to determine that PQRS is a parallelogram. So for number 1, if you're given that PQ is congruent to SR and you're given that PS is congruent to QR, can you determine that that's a parallelogram? I would say the answer is yes, because if both pairs of opposite sides are congruent, then you have a parallelogram. Number 2, if you're given that PQ is congruent to SR and you're given that PS is parallel to QR, is that enough information to determine if it's a parallelogram? Well, we had one reason that said if both pairs of opposite sides are parallel, we don't have that. If both pairs of opposite sides are congruent, we don't have that. If one pair of sides is both parallel and congruent, we don't have that either. We have one pair that's parallel and one pair that's not. So this one is not enough information. So can we determine it? No. The third one, if you're given PT is congruent to RT and you're given ST is congruent to QT, do we have enough information to prove this is a parallelogram? My answer for this is yes, it is, because the diagonals bisect each other. Last but not least on this slide, number 4, if you're given PQ is congruent to SR and you're given that PQ is parallel to SR, do we have enough information to prove this is a parallelogram? The answer to this one is yes, we do have enough information because we have one pair of opposite sides that are parallel and congruent. So this slide's useful because please notice and make a note to yourself that these two things are very different. This one we don't have enough information, but this one, because we happen to have one pair that's both, it is a parallelogram. So getting into proofs, this is the first time that we want to formally prove, is this shape a parallelogram? And we have to use one of these 5 reasons to do so. So we are given that CD is parallel to AB. So as soon as I'm given parallel lines, I'm thinking that these have to be transversals, which could lead me to angles. Well, let's see what else we have first. We have EDA is congruent to CBF. So we have CD is parallel to AB, given, and we have EDA is congruent to CBF, given. Now, just to be a little bit more simple, I'm going to call EDA angle 1, and I'm going to call CBF angle 2. So you could also write this as angle 1 is congruent to angle 2. What I noticed from there is because we're given these two lines are parallel, and that's a transversal, 1 and this angle, which I'll call 3, are alternate interior, so they must be congruent. So I'd write angle 1 and angle 3 are alternate interior angles, and then I would write that angle 1 is congruent to angle 3. This reason would be assumed from diagram, and this reason would be because if I'm given parallel lines, then my alternate interior angles are congruent. Now this is quite handy because I'm given that 1 and 3 are congruent now, and I'm given earlier that angles 1 and angle 2 are congruent from this given. So if we think about the chain rule, if both 3 and 2 are congruent to 1, these two must be equal to each other. So I can use the transitive property. I could say, I know now that angle 2 is congruent to angle 3 because of the transitive property. And that would be from reasons 2 and 4. And now if I look at angles 2 and 3, these are corresponding angles, and they're congruent. So if I have pairs of corresponding angles that are congruent, that could help me prove that this line and this line are parallel. And once I prove these two blue are parallel, and I'm given that these two red are parallel, I know this has to be a parallelogram. So if I take it from there, I'm going to say angle 2 and angle 3 are corresponding angles, assumed from diagram. Step 7, I could say that line AD and line BC are parallel. So AD is parallel to BC because if corresponding angles are congruent, then I have parallel lines. And now I know that both pairs of opposite sides are parallel, so I have my proof. I now know that ABCD is a parallelogram. You could also just write the word parallelogram if you want to. Your reason would be if both pairs, underline both, of opposite sides are parallel, then parallelogram. Now moving on to our next proof. Given ACDF, the large outer shape, is a parallelogram, and given that AFB is congruent to ECD. Again, I will call these angles 1 and angle 2 for simplicity. We want to prove that if we know this is an outer thing is a parallelogram, that the inner four-sided shape is also a parallelogram. So we're probably going to have to go towards some congruent triangles. Let me first write down my givens. And as I'm doing so, I want to let you know that we're going to continue on with the next video because I only have 15 minutes here. So let's at least write down the givens. Is a parallelogram. Okay, if you could join me on the next video, I want to start fresh. So please pause now and go to the video number 2. Thank you.